Hello and welcome to Cooking with Chemistry, a special kind of cooking show where we bake a delicious treat and talk about the chemistry involved in the making of the dessert. My name is Ricky.
I'm Elizabeth.
I'm Andrew.
And Sophie. Today we will be making snickerdoodle cookies.
Sounds good. Let's get started with the snickerdoodles.
First, we need to get our ingredients ready. We are going to need 1 cup of butter, 1½ cups of sugar, 2 large eggs, 2 3/4 cups of flour, 2 teaspoons of cream of tartar, 1 teaspoon of baking soda, 1/4 teaspoon of salt, 3 tablespoons of sugar, and 3 teaspoons of cinnamon.
Alright, now that we have all of our ingredients together, let's get baking. Preheat the oven to 350 degrees Fahrenheit. Okay, so first mix eggs, butter, and 1½ cups of sugar thoroughly in a large bowl.
Combine 2 3/4 cups of flour, 2 teaspoons of cream of tartar, 1 teaspoon of baking soda, and 1/4 teaspoon salt into a separate bowl.
Now blend the dry ingredients with the butter mixture.
We have made our dough, and now we need to chill it along with an ungreased cookie sheet for about 10 to 15 minutes.
In the meantime, mix 3 tablespoons of sugar and 3 teaspoons of cinnamon in a small bowl.
Okay, our cookie and sheet is done chilling.
Alright, here comes the fun part. Scoop about 1 inch of glob of cookie dough and put it into the sugar-cinnamon mixture.
Then, coat the dough by gently rolling the ball in the mixture.
And place it on an ungreased cookie sheet.
Keep doing this until you run out of dough.
Now we put the cookies in the oven and bake them for 10 minutes.
That was fun! Now, while the cookies are baking, let's talk about the chemistry involved. In other words, what is really going on inside the oven right now?
So many different things. When you put the pan in the oven, you set off a bunch of chemical reactions that transform one substance, dough, into another, cookies. Since the dough is in the hot temperature of the oven, the chemical reactions that occur will take place pretty quickly. Increased temperature speeds up kinetic energy, causing more frequent collisions between molecules. Collisions are what cause a chemical reaction to occur, so with more collisions, the reaction rate speeds up.
As the cookie dough starts to heat up, the butter inside it melts, causing the dough to spread out because it loses its structural integrity. Butter is an emulsion, or a mixture of two substances that don't want to stay together. In this case, it is water and fat, along with some dairy substances that help hold them together.
As the butter melts, it traps water is released. As the cookies get hotter, the water turns into steam, and the cookie starts to rise as vapors push through the dough. Eventually, sodium bicarbonate, or baking soda, reacts with acid in the dough to create carbon dioxide gas, which raise up the cookie even farther. Soon your cookies get dried out and stiff and crack, spreading across the surface. The steam that was bubbling inside evaporates, leaving behind air pockets that make the cookie light and flaky.
A change also occurs in the eggs of the cookies. Eggs are composed of dozens of different kinds of proteins. The proteins in an egg look like coiled up balls of string. When they're exposed to heat energy, the protein strings unfold and get tangled up with each other. This linked structure makes the runny egg nearly solid, giving body to the squishy dough.
Then the magic really starts to happen. Just as the cookie is almost finished baking, two chemical reactions occur that fill it with hundreds of flavors and add its nice brown color. First off, there's caramelization. As sugars in the dough break down, they transform from a clear, odorless crystals into a brownish scented liquid with tons of aromas and tastes.
The second reaction that takes place is called the Maillard reaction. This reaction packs the cookies with even richer tastes. Maillard reactions result when proteins and sugars break down and rearrange themselves, forming ring-like structures which reflect light in a way that produces a range of flavor and aroma compounds. It causes the toasty, nutty, and savory flavors of the cookie and helps to darken the cookie's surface.
As a result of these multiple chemical reactions that occur inside the oven, we get our delicious snickerdoodle cookies.
The pan we use to bake the cookies on is also a part of the chemistry involved. Convection occurs inside the oven as the heat circulates throughout the oven, heating up the pan and the cookies. Conduction also occurs between the pan and the cookies on it. Conduction is the movement of heat energy through matter by the transfer of vibrational energy between atoms and molecules. We use a metal pan to bake our cookies, and this matters because the material used determines how fast the cookies will bake, depending on how fast it conducts heat. Thermal conductivity determines how fast the cookies will bake because it describes how readily a material will give or take heat through conduction. A material with high thermal conductivity will transfer heat quickly, like metals. Heat capacity is another factor, as it refers to how quickly a material's temperature changes with the addition of heat. Metals have a relatively high heat capacity, which means that their temperature will increase more slowly than others. Overall, metal is a material that conducts heat relatively quickly than others, which is why we chose to use it.
The cookies are ready.
There is so much chemistry involved in baking cookies, and all the chemical reactions are so important because they give us the delicious snickerdoodle treat that everybody enjoys.
Thanks for watching Cooking with Chemistry.
See you next time.